oxidant is something which will spit out an oxygen, and that single oxygen changes the chemistry of your body. A compound will either become more reactive or less reactive when you give it an extra oxygen. They still bonding sites? Might be one way to say it.
So that's what that one is over there. That says look out.
Right, exactly. So here's another oxidant. It's called peroxyacetyl-nitrate, or PAN. And that is, please look up, anything stuck to this thing, and it's a problem because of this one. Look out. That is your extra single oxygen. That's your loosely attached clingy single. That's your usually diatomic thing that is ready to become a single. It's going to jump out in your body somewhere and stick to something else in your body somewhere. I want to try to review because I know that I have a broad spectrum of chemistry levels. If you're good at chemistry, please wear earmuffs for a minute. There are facts that some students will need to write down because they don't speak chemistry. Fact number one, diatomic gases need a buddy system. The diatomics are Hofbrinkel. They need to be in a buddy system. When they are single, they are clingy. You should probably write that down too. And finally, these are dangerous for us because being clingy, they interrupt our internal chemistry. The biggest one to worry about is an oxidant, something with a single oxygen stuck to it. Those of you who speak chemistry, I think you've already heard all of this. But for the rest of you, the Hofbrinkels are clingy. They need to be in a double system. When they are singles, they will bond with anything else they can find. And that's bad, especially like oxidants, because that disrupts internal chemistry. Can I clear this up for anyone? I'm going to pretend from now on like everybody knows this. So I really want to make myself available for those of you that don't speak a lot of chemistry to see if I can cover this wound with a Band-Aid. Can I help anyone with their chemistry on this issue? You're either really fast learners or really bad liars. I'll go with fast learners. Okay. So please look up. There are two big reactions that happen in the atmosphere. When we add these to the atmosphere, they make that. And ultraviolet, that plus ultraviolet makes the loose one. That loose one finds oxygen to make ozone, and that's a problem because that's where we got our oxidant that's dangerous for you. There's another way to do this too. Nitrogen oxides and VOCs can directly make these, which are whatever you want with the peracyl nitrate group on it. And this is the scary one. It is, again, an oxidant. So this is the one that everybody must memorize. NOx plus VOCs in our atmosphere create oxidants that are dangerous for us.
NOx plus VOCs plus atmosphere equals that.
Yeah, this is just atmosphere. Oxygen and ultraviolet, that's always there. That's what I mean. Our atmosphere is a chemistry lab. It's just waiting for the ingredients. So these ingredients, plus the stuff that's always in our atmosphere, make these dangerous oxidants. Yeah?
The stocks don't react with
to a lesser degree. Sulfur oxides are more stable than nitrogen oxides, so you can aggregate oxygens onto salts, but they don't make as many oxidants. I don't know anything about that. I just heard that fact. I think, yeah, more rain, so more stable bond, I'm guessing, more electrons, maybe that's it. Okay. I'm almost out of time, and so I just want to do a really, really quick review before I jump to another study goal. Remember, first of all, that in our atmosphere, a lot of stuff happens without us trying. One of the things that's really scary is some of the ingredients we put out there result in stuff that's really bad. Oxidants are bad for us because they disrupt internal chemistry, respiratory problems. Specifically, NOx plus VOCs and stuff that's always in our atmosphere make these oxidants that are dangerous. This is like bad for you. Does anybody want to talk more about number 28? Then really quickly, I'd like to talk about number 29. Why is rain naturally acidic? Right. No. Because CO2 is always in the atmosphere, and you already know that oxide plus water makes acids. So just so that we're clear, all rain is acid rain. It's not going to burn you. You're not going to melt. It's not going to kill you. You can drink it. You can swim in it. So chill out about the acid thing. It's not the kind of acid that you would use to dispose of dead bodies. It would be sweet, but it's not. Now, please look up. Because the acid rain issue is not so much this one. This one makes a weak acid that we don't really care about. But these two make either a strong or a very strong acid, and these are really gnarly. Technically, if you got enough of that, you could probably dump a dead body with it.
H2SO4?
Yeah.
All right, good.
Tomorrow we will talk about Monday, we will start with the impacts of acids. But remember, this is mandatory knowledge for AP Environmental Science students that oxides plus water make acids, always. So we've got like a minute and a half, maybe seconds. What can I answer for you? Everybody's feeling super Friday. I can see it. I'm feeling it too. Can I help? Pancreatitis and DC cold or whatever. And time change. What?